The first talk in this session will be given by Jason Coposky on the iRODS development update 4.0.2 to 4.1.0, and I suppose that includes 4.1.2.
Hopefully. Do you have the slide changer? Is this thing working? Okay, excellent. Good morning, everybody. So I'm going to give you a quick overview of 4.1, and hopefully we'll have lots of questions from there. We have just released 4.1.2. We've solved some minor packaging issues and upgrades and whatnot, but all of the software that is in 4.1 is the same as the software that's in 4.1.2. So last year, we had the merge. So we merged with the community code from 3.3.1 with Enterprise iRODS 3.01, and we had the consortium release. I believe we released 4.0.2 on a plane on the way into the users group meeting, which I think is an amazing bit of technology. Our focus for 4.1 ultimately was to take all of the great software that we had with the 4.0 release, all of the excellent features that we brought back on board from the community code, and really make that an enterprise quality product. So our focuses were on, hardening and making iRODS enterprise ready, as well as all of the requirements that came from the community and our membership. So the first area of focus was in hardening was static analysis. So we have an excellent tool that's made available to the open source community called Coverity, which is a industrial grade static analysis tool. We're running CPP check and stack as well in continuous integration. And then we had all of our membership and community input. So we're getting a very good set of traffic and a lot of good conversation on GitHub, and I feel that's really helping us make a better product overall. And then we've had some general improvements that just came straight out of the consortium. And this is my favorite slide. We have fixed, well, Zoe specifically has fixed over 1,200 issues that have arisen straight out of Coverity, and that has made this a much better project and a much better product. So we now have a very solid set of confidence that the software that we've created is actually doing what we claim that it's doing. A lot of issues that were on GitHub have simply been closed because they have been fixed by issues that were identified by Coverity. So we are now down to 0 issues, and this includes external libraries, so we have actually been providing back to the open source community as well, which I find is amazing. And we are keeping track of all of this in continuous integration, so anytime a new issue arises, it gets fixed immediately. We've closed over 192 bugs that have been coming from the community up on GitHub, as well as anything we find in continuous integration. So we've ironed out some permission inconsistencies. Parallel transfer now works over multi-home networks, which is great. So we're no longer referencing everything specifically by static IP, but we're using host names everywhere within iRODS, which is why keeping your host names correct is very important. IRSync has had some fixes and some other minor updates as well. The third general improvements that we've provided is we're starting to, we're continuing to push the plugin architecture down into the existing code that we have brought over from the community build. We're moving more of the compile time options out of iRODS and moving those into our new configuration files. So things like the number of threads that you want to use for parallel transfer and whatnot have all been externalized to our configuration. We're updating a couple other, minor scripts and whatnot that have been packaged as well, like the vacuum, and we're actually removing some code. We're removing some of the features that were never fully completed or have not really been fit for an enterprise deployment, like run as root is no longer an option, or some of the other roles that have not been fully fleshed out, like storage admin. If these are features that are important to the community, I'd be much happier to re-implement them in the new architecture rather than trying to make do with what we had. From an enterprise readiness point of view, we have moved all of the configuration to validated JSON. So all of the different formats that we've had for the configuration files have now all been unified. This is schema driven. The versions of the schemas will actually be moving along with the versions of iRODS at their own pace as necessary. Using that JSON, we've added the ability to do some introspection within the grid. So we can actually capture the state of an entire zone as a validated JSON document, and you can keep that for configuration. We have a grid-wide control plane now, which will allow you to do things like graceful startup or graceful shutdown and pause. And we have a new client hints API. So for the configuration point of view, we have a server config is now server_config.json, and the rest of the configuration files that you're familiar with are now moving along to this new scheme that we have here. If you are upgrading from 4.03, we will automatically generate the JSON files for you. Once the JSON files are in place, they are now the source of truth. From an enterprise readiness point of view, we have the zone report. There is a new I command that is only capable of being run by the administrator called iZoneReport. It will go out over a new iRODS API and query every one of the servers for all of their configuration, including your plugins, all of the JSON files that you have. It will scrub all of the secrets out of the JSON files for you, package them up, and ship them over the wire to the client. So you now will have a validated JSON document describing the entire zone, which we feel is going to be very important moving forward. We can, and you'll hear about this later, we can actually take these JSON documents and drive the launching of a topology within our cloud infrastructure at Rensi just from this document now, which is very helpful for continuous integration. The control plane. This allows us to speak to iRODS from a side channel for administrative purposes. So from the community code, if you were going to bring down a grid, you had to go log into every one of the servers and then stop those processes and stop them hard. If you had any connections, there was no way to know. Given the new control plane, you can actually gracefully pause or resume the grid, as well as stop all incoming connections and allow the existing connections to finish their work before you do any upgrades, and then gracefully shut down the entire grid. This will also give you the ability to grab the state of the grid itself. So you'll know the number of processes that are in flight, how long they've been in flight, what the process IDs are, and it'll give you a better understanding of what is happening with your deployment. Client hints. This is a new API that we are providing to allow clients to understand the configuration of the grid so they can make better choices about how they're going to interact with the grid. This is also a JSON document that is schema-driven and will march along as iRODS gains new capabilities to allow you to better interact with the grid from a client perspective. We've also had, of course, plenty of membership and community requests. So we can put with atomic data, we can now pass key value pairs through to the resource plugins to allow you to better interact and configure the existing state of that. I shouldn't say configure, to better interact with the storage capabilities of your chosen deployment. Zero-length files now have the capability of triggering the resource compositions. And my favorite one is the weighted pass-through resource plugin. So right now, zero-length files will also replicate to archive resources in a compound resource deployment, as well as replicate in any other capabilities that have been encoded in your resource hierarchy. And this is interesting. iPut now has the ability to package metadata as well as ACLs with that API call. So if you have a script that is ingesting data, you do not have to continually check iRODS to make sure your data is at rest before you start modifying anything about that data object in the catalog. And iPut and iGet now have a key value pass-through. So you can define key value pairs to interact with your resource plugins. So if you have a DDN WAS deployment, for instance, and you want to pick a separate policy that was configured there, that plugin now has the capability of reading these key value pairs and making decisions about how to store that data for you at the storage layer. So we're creating a channel between the client and the storage itself that just simply passes through iRODS to allow you to interact with your storage directly. And the weighted pass-through plugin. So as been mentioned before, resource compositions make decisions about how data is ingested or data is accessed by votes. The weighted pass-through is simply now a shim that you can add into your resource hierarchy and wait the votes that are coming up from the children. So if you want to, say, for instance, create a read-only archive, you simply set the write to 0 in a weighted pass-through, and now anything that is underneath that weighted pass-through can no longer take write operations because it will simply vote 0. Any questions? Yes, sir.
The control plane, you said, can report a graceful shutdown.
Yes.
Well, I'm wondering if you can get an estimate for the time, the termination.
You cannot. So the question is can you get an estimate of the time that it's going to take the entire grid to shut down? I would say no, because you do not understand. There's no way to understand what the client is doing. What you can do is give it a timeout period. So you can ask it to gracefully shut down and wait 10 minutes, and if that 10 minutes is up, it will be a hard stop. No other questions? Okay. Yes, sir.
John Nichols from Sanger Institute. I have a question from one of our developers about these atomic metadata operations. Apparently, they've got an issue with, in their testing, that there's no locking done with this. So when there's a large write going on that takes a long time to commit over the network, and some other process is interacting at that point, you can land up with basically nothing getting written to disk. I probably take this offline, actually, because I don't fully understand the email I've got from the developer here. They want to know a bit more about it, and they say the situation is now worse than it was previously.
That's a live support question. There is read and write locking with the --w lock. So I would consider trying that. One of the things that we have added is from the API plugin point of view, is to swap in a new API plugin to override an existing API plugin. And one of the upcoming experiments we're going to work with is to actually start working with external properly distributed locking systems like Zookeeper. And so we will write new locking APIs that will use other externalized services for that purpose. We can ship those as separate packages, so it's once again a runtime and deployment option.
I'll catch you later.
Okay.